In this video, we're going to take a look at an example for a standard normal distribution in which we are given probabilities and we want to use those probabilities and find data values that are associated with them. Right? So we're going to go from a probability back to a data value. Our previous video looked at starting with a data value and using a data value and going forward and calculating a probability. So this is going the other direction. So here we have a bone mineral density test. Just like in our last video, it can be used to find the likelihood of developing osteoporosis. Results are normally distributed, so that tells us it's a normal distribution. Has a mean of 0, and it has a standard deviation of 1. Right, so it is a standard normal distribution. We want to know first what bone density separates the lower 5% of the data. Right, so here we have our mean is equal to 0. Standard deviation we know is equal to 1. We want to know what is the data value. So the value down here we don't know, but it's going to separate 5%. So the area in that tail is 5%. And so we will write that area as a decimal. 0.05. And that 0.05, we're going to take that and we are going to go straight to StatDisk with that. And so over in StatDisk, statdisk.org, we are going to choose analysis, probability distribution, and then a normal distribution. Here, the area from the left, so the area to the left of the value that we have is 0.05. It's 5% is the area to the left. We want to try to find out what is the z-value associated with that. That z-value is negative 1.64. If I go to 3 decimal places, it will be negative 1.645. With that z-value, we would then convert it to a data value. So x is equal to the mean plus the z-score times the standard deviation. So for us, when we're dealing with a standard normal distribution, when the mean is 0 and standard deviation is 1, this is really simple. The mean is 0. Standard deviation is this value up here, so the negative 1.645 times 1, and we get negative 1.645. So a bone density of negative 1.645, that would separate the lower 5% of all bone densities. So if someone has a bone density of negative 1.7, they're in the lower 5%. If someone has a bone density of negative 1.5, they are not in the bottom 5%. Our next question, we want to know what bone density separates the upper 2%. So again, our mean is 0. Our standard deviation is 1. We want to know this value up here that has an area of 2% to its right. We rewrite that 2% as an area, or as a decimal, 0.02. Now, StatDisk, it takes in not an area to the right, but StatDisk takes in an area to the left for the normal distribution. And so if 0.02 is the right area, what is the area to the left? Well, that area to the left is going to be 1 minus the 0.02. And so if 2% is to the right of this value, 98% is to the left. So we're going to take that 0.98 and we're going to enter that into StatDisk. Right, so the cumulative area from the left is 0.98. We will evaluate it. And when we do that, we get a z-value of positive 2.054 if we go to the third decimal place, if we round that third decimal place. So 2.054 is our z-value. Let me go back to that StatDisk page and just show you a couple other things. Here, notice that that right area is 0.02. So we can get some confirmation that we've done some of these things a little bit correctly. That area to the left is 0.98. So those things seem to match up. The next thing that we'll take a look at is a slightly different question. Here we want to calculate the 98th percentile. And so as we calculate our 98th percentile here, we want to know, what does 98th percentile mean? Well, something's in the 98th percentile if it has a value that is more than 98% of the other values. So we want to know, what is this value that has an area to its left of 98 or 0.98? And what you might notice is this is a fancy way to ask exactly the same question from above. 2.054, that is the bone density that is more than 98% of the other bone densities. In our next video, we'll take a quick look at critical values, and those will show up in a variety of places, and as we calculate here in the future, things like confidence intervals and perform hypothesis tests. We will talk to you then.